Welcome again, everybody, and thank you for joining our global webinar day on SDN configuration and monitoring with Infosim StableNet. My name is Marc Scheib, Director of Sales Europe with Infosim, and I will be your moderator for today's event. Joining us as presenters are my colleagues Marc Scheib, one of our consultants. Good morning, Marc. Or good afternoon, I'm sorry.
Good afternoon, Dietmar.
And Thomas Hoehn from our development team here at the headquarters office in Würzburg, Germany. Good afternoon, Thomas.
Good afternoon, Dietmar.
So these two gentlemen will guide you through our presentation and live demo. Before I hand over to Marc and Thomas, I just wanted today's audience to know that all of you are automatically muted to keep down the background noise. So in order for us to answer your questions, you will have to type them in the questions window at the bottom of the GoToMeeting application. Marc and Thomas will answer all questions right after the presentation in our Q&A session. Also, please note that this event is being recorded and all registrants will be notified via email tomorrow on how to access the recording. Well, that's all from my part for the time being. Now I'd like to go ahead and turn things over to our presenters, Marc Scheib and Thomas Hoehn. Marc, I think you're the one who's going to start.
Yes, right. Thank you, Dietmar. Thank you to everyone who has attended the webinar this afternoon. Again, my name is Marc Scheib and I'm a consultant here in Europe with Infosim. And it's a pleasure for me to present you our webinar this morning with the topic SDN configuration and monitoring with Infosim StableNet. I will guide you through the presentation, and my colleague Thomas Hoehn from the development team is joining us as well with a live demonstration on this topic. Thomas, do you want to add some few words?
Yeah, hello to everybody. I'm a developer from Infosim and I will give you the live presentation with the actual functions of SDN in combination with StableNet.
So in this webinar, at first we will look into the concept of SDN and we will give you a small introduction on this approach. This includes the components that are used in StableNet, like the OpenDaylight controller that we are using for our example, and the protocol that is used for communication in SDN, called OpenFlow. I will give you some more infos on this point at the given time. Afterwards, Thomas, as just mentioned, will give you a live demonstration of our testbed and what we are currently able to do with StableNet and SDN regarding configuration and monitoring. For those of you who are not familiar with Infosim or our product StableNet, we have some brief bullet points here about us. One of the most important probably is that we are around for about 10 years. So I guess for most of our listeners, we are a name, but if we are not, it's just important to know that we are around for a number of years. We've been growing quite rapidly, and we are highly profitable. We have some subsidiaries all around the world, in Singapore, for example, or in the USA, and of course we have the headquarters here in Germany, where me and my two colleagues are located. With our tool StableNet, we primarily focus on large enterprises and telcos, and that is what our product really aims for. I would say the bigger the telcos, the better for us, because we have a lot of advantages here when we go into the large-scale telco service providers. The product itself does many things like service assurance, or we have a big ability of discovering devices. We have this proactive performance and fault monitoring, as well as network configuration and change monitoring. And we are always focused on developing our product in means of improving performance, adding additional features and adjust it to the needs of our customers. And we also want to adjust the product to changes in the network design or network architecture. And especially this last point is of interest for us here, as with software-defined networking, another new concept of designing networks evolved that needs to be handled in configuration and monitoring terms. But at first, I want to give you some points why it actually is necessary to keep these network changes in mind. Currently there are many limitations to networks, and I think people can mention a lot of points here, and I only want to look at some points with you here. As you can see, here the traditional client-server architecture is shown, and in contrast to this architecture, today's data centers operate in a design compared to east-west communication. So you can see here the east-west traffic. In traditional data centers, we have this clients communicating with only one server where all the data goes over this one server. And today's data centers operate in the VRN of the data center itself. So if one host is querying some data here, the data is taken from this database or from this database. So there's a lot of traffic in the data center itself that has to be handled. And in addition to the data that is located in the data center itself, there are also a lot of other complex protocols that are designed to connect these hosts in the network. And the problem with this complexity is that it leads to a very static network, and it's very hard to deploy new hosts. So think about, you want to add a new machine to your network. The first thing you always have to do is adjust the routers or switches, or add some firewall rules, update access control lists. You have to adjust the VLAN configuration or quality of service parameters. And it's a very hard task to adjust all this for every new device. Additionally, you have many different vendor models like Cisco or Juniper, which all use different versions and different configuration languages. It's always hard to know every single configuration language or adjust it. And additionally, many enterprises today operate on IP converged networks for voice, data, and video traffic, and they are trying to be able to provide differentiated quality of service levels, which normally is easy, but the provisioning of these resources normally is highly manual, and it takes a lot of time to adjust, in some cases, thousands of devices. So what is needed here is a network configuration or network architecture that is especially made for this task. So we can talk about something like a virtualization of a network layer, where it is possible to easily add or remove or modify devices in the network. And of course, in addition to that, an easy network setup is needed that allows these simple configuration steps. Also of importance here may be the use of layer 4 information to forward traffic. So, for example, we want to take applications in our network like voice over IP or video streaming, and these packets should be treated in a different way than other packets. And we want this to be easily done. And as the last point that I just mentioned before on the limitations, of course, we want to break up the vendor dependency and their equipment product cycles to easily deploy new capabilities and services in our enterprise networks. And all these needs for a new network architecture resulted in the concept of software-defined networking, or in the short form SDN. And this is trying to solve the previously mentioned issues. The idea of SDN is derived and evolved from the idea of OpenFlow, which was developed at around 2008 at Stanford University. And just to give you some hints on what else will follow, OpenFlow is the protocol that is used for communication between the controller of SDN and the SDN devices like switches, but I will go to this point in the next slide. SDN itself comprises several main principles, so some of these are noted down here, as you can see. So, for example, at the first principle, we have this physical separation of the control plane and the data plane. Down here you can see a traditional switch with its data plane and network control plane, and every switch has a controller which is responsible for doing the intelligence in the network, so forwarding packet, checking on which packet has to direct it to which output port, etc. And what SDN is doing now is separating this network control plane from the data plane and putting all these controllers in a central control plane entity, which is often called controller. And this at the same time results in the second principle, the logically centralized entity. This entity can consist of multiple physical or virtual instances, but at the end it will behave as one single component. And SDN itself brings some open interfaces with it, like for example the southbound API, which can be seen here, and located in the southbound API is the OpenFlow protocol I just mentioned. This is OpenFlow logo you can see here. And there are additional interfaces like, for example, the northbound API, with which you can add your own applications to software-defined networking. So this is what we are doing. We add StableNet, we add northbound API to an SDN network or to the controller. And one of the last principles, and maybe one that is the most important one, is the programmability of SDN networks. Sorry, one slide ahead. This programmability is enabled through the external controller and the interfaces. So for example, what you can do here is add some specific modules to the controller, or directly use the northbound API to add your own products, like in our case, as I mentioned, StableNet. And this is what we did in our monitoring and measurement solution or configuration solution. And as I mentioned several times before now, OpenFlow is that term that is often associated with SDN, but more precisely, OpenFlow represents the communication between the control plane or the controller and the switches in SDN. And these switches are not comparable to traditional switches because they are simply bare metal switches with no intelligence. This means that the configuration comes completely from the controller, and the switches need to be able to exchange messages with the controller. And the OpenFlow switch specification is doing this or is describing this communication, or the ability that the switches must support to communicate with the controller via OpenFlow. For our webinar, we now only want to focus on some simple introduction to this specification, mainly these parts of the specification that are of interest for presenting you our configuration and monitoring of approach. And what is important here to know is that OpenFlow is changing from the traditional packet switching to flow switching. I will show you exactly what this means in the next slide. Before, we need to know that this flow switching is handled by using so-called flow tables. A switch can contain multiple flow tables, but we are also focused on only one flow table here. And this flow table contains several flow entries. A flow entry is shown here in a very simple way. It's built up out of matching fields, some action fields, and flow statistics. And I can define these two components, the matching and the action fields by myself, and the flow statistics are then created by the switch itself for every single flow entry, and I can, for example, use these flow statistics to present some information in StableNet, for example. But of course there are some other statistics like port statistics which check how many packets come into a port or how many packets leave a port, how many packet errors I have, and so on. So now that we have these flow tables, on the one side we have the ability to add flow entries manually, and on the other hand it is possible to add flow entries when a packet arrives at a switch. So we now take a packet in at our switch, and the switch is now checking the header information for the header information of the packet for matching with flow entries in our flow tables. In the beginning, of course, our flow tables are completely empty. So what is happening here is that the switch is forwarding this single packet to the controller, and the controller normally now knows what to do with the packet. So this means he is also analyzing the header, for example, and decides then on some policies you've defined before, or depending on the applications you have added to your controller via Northbound API, where to forward the packet to. So it's writing a flow entry in your flow table which tells the switch what to do with future packets that will come in and that belong to that flow. So in some of the next steps, another packet is arriving at the switch, and the switch now can match a specific flow entry to the packet, and it will directly forward this packet to the corresponding output, and it will update statistics on that flow entry. And now the last thing we need to add to this SDN concept is, of course, the intelligence or the controller. And we are using the OpenDaylight controller currently in StableNet, but of course we support some other controllers like Floodlight or the Beacon controller. But OpenDaylight is one very extended controller, which is an open source project hosted by the Linux Foundation, and many partners from industry are also developing this controller with one general goal. So they want to accelerate the adoption of software-defined networking, of course, and they also want to create a solid foundation for networking function virtualization. Another aim is that they want to establish their own concept of SDN and at the same way influence the market of SDN. So every company wants to establish their own concept in some ways of SDN, but with the OpenDaylight product there will be a common concept. The controller itself is an open source framework, so you can easily extend it because it's module based and multi-layered. So I have a layer for the communication with the network devices, I have a core layer, and I have an application layer to easily add my own applications. And of course I can write directly modules for the controller which are loaded with the controller. And we have used both approaches, so we added a module to the controller and we were now able to communicate via the module with the OpenDaylight controller via our StableNet. And that is what our development team is currently doing. So Thomas will give us now some insights on what is going on in the dev corner and how we are extending OpenDaylight to work together with StableNet.
All right. Thank you, Mark. Mark, you want me to do the switch over to Thomas?
Yes,
so you guys don't have to fight who can hold the mouse. Just a second.
Yeah.
All right. Thomas, you're up.
Yep, a moment please. Thank you, Marc, for the explanation of SDN and OpenFlow. Before we start with the live demonstration, I want to show you our test lab. As you can see, it consists of 4 components. We have 2 devices which are connected via an OpenFlow switch. As OpenFlow switch, we use a Debian Linux device with an installed OpenV switch. The OpenV switch is a virtual software switch and is great for demos, tests, or for development. The OpenV switch, respectively OpenFlow switch, is connected to the OpenDaylight controller, which is extended with our own modules. We use these modules for the discovery and device measurement. Actually, we have 2 parts for SDN. The first part is to use StableNet for passive measurements of OpenFlow switches through the controller, and the other part is that we use StableNet to configure the OpenDaylight controller via a CLI interface. StableNet uses the CLI interface to log in into the controller and execute commands. Okay, now let us switch to the live demonstration of StableNet. Here in the measurement tree you can see the 4 test devices of the SDN group. We have the OpenV switch, our OpenDaylight SDN controller, and the 2 hosts. In the device automation theme we have the options to make a backup of the controller configuration and start configuration jobs through the controller. At first we start a simple backup job so that we can see actual configuration of the controller. The job has normal settings, and this is known from some other devices without any special configurations. Okay, let's start the job. As tag I use simple example. So I need a little bit time for the end of the job. Yes, and as a result we can see the actual configuration of the controller. Additional to the output of the backup, we can also run device info commands on the controller. For example, here is a command which has as output the connected switches with some additional informations. The output of the backup and the device info commands can be also used in policy check jobs to control the configuration, to control the right configuration of our controller. And now our aim is to add a flow to the database of the controller to enable or disable the flow on the switch. Therefore, we use StableNet, a StableNet configuration job as simple flow pusher. For the controller configuration, we have 3 different types of jobs. The simple configuration job, the snippet-based, or the template-based. We use in the demonstration a template-based configuration job. This job is defined in an XML file and offers input parameters to configure the flow more precisely. With this input fields, it is easy to define the flow and add it to the database of the OpenDaylight controller. For example, we use here the switch datapath ID, the name of the flow, which is important for the which is used as ID into the OpenDaylight controller, the import for the flow, the MAC address, the source MAC address, the destination MAC address, and the output of the output of the switch. If we start the job, StableNet adds the flow to the database and starts automatically a backup after the configuration. Okay, let's start the job. So you need a little bit time for the job. So Okay, now we have a new backup, and we see in the configuration that we have added the flow entry with our source and destination MAC address with the port numbers for this switch. And here you can see that the flow is not active. This means that the flow is stored in the database but not pushed to the switch. With an additional configuration job, we can enable or disable this flow into the switch. Here we use also a template-based configuration job, and we use the database ID of the switch and the name of the flow to enable or disable the flow with dropouts. Okay. We have now seen the configuration part of the StableNet. Let us start with the measurement part of StableNet. StableNet adds the measurements during the discovery automatically. Therefore, we have developed our own module for the OpenDaylight controller. This module is used to receive device info commands, device information from the controller to add the measurements automatically. Moreover, with this module we can query the statistic values of the flow or the switch for some measurements. Actually, we measure the port statistic of the port statistic of the switch, the count of the flows of the switch, and the count of the switches which are connected to the controller. Okay, let's switch to the demonstration. We can see it in the measurement theme. Let us start with the number of switches which are connected to the controller. Therefore, we have a measurement. For the measurement parameter, we need the IP address of the controller and the used port from our module. And the former measurement data can be plotted through the analyzer. And as you can see, we have only one switch added to our controller, which is the right value in this case. The next measurement part is part of the switch, in our case the OpenV switch. For this measurement we need, for the flow count measurement, we need a little bit more information for the controller. We need the IP address from the controller, the used port, and additional we need the data path ID of the switch so that we can inform the controller which count of flows from the switch we want. And the last feature is the port measurement. This is part of the interfaces. We use the OpenFlow statistic value of the port for a passive measurement. For this measurement we need the same input parameters as by the flow count measurement, the IP of the controller, the port of the module, and the database ID, and additionally we need the number of the interface which we want to measure. For visualization we use also the analyzer, and if we go to seconds, we see that we have a little bit traffic in our network. We have here a state measurement for the information if the port is down or up. We have traffic measurements like in packets and out packets, and in kilobytes and out kilobytes, as some error measurements which give you the information that you have a problem on this port or not. Okay. Now we come to the end of the presentation. At this point I want to summarize the presentation. We have seen that SDN offers the ability to simplify the network configuration and change management, and that we have a central entity to control the underlying network, which is simply called controller. In our demonstration we have used the OpenDaylight as controller. At this point it should be mentioned that the OpenDaylight controller is only an example. We support also some other controllers like the beacon or the floodlight controller. In StableNet we have seen that we can use the configuration jobs to configure the controller. We can make configuration backups and execute device info commands on the controller and store the output in StableNet. And we have used StableNet as flow pusher through a configuration job. Additionally, we have seen that StableNet uses the SDN northbound API for passive measurements. Okay, I hope you have enjoyed the presentation, and if you have questions, feel free to ask.
All right, Thomas, thank you very much. I thought that was pretty good and pretty informative. We have received a number of questions during the presentation. Most of them we were able to answer directly. There was one that I answered publicly, or actually two. One was a request for the presentation slides. Yes, to repeat myself, they are available in PDF format. Just drop us a mail. The email address is in the chat, so that we can send you that PDF real quick. Another question was if this webinar has been recorded. Yes, I said that in the intro dialogue already. A link to the recording will be sent to everybody who registered for this webinar tomorrow. And there was one question that I thought might be interesting from our audience. If we just support the OpenDaylight controller with StableNet, I think, Thomas, you answered that one in your very last slide. But the question goes on, if we also support vendor controllers such as the Cisco EPIC or the HP SDN, for instance. And to my knowledge, and Mark or Thomas, you may correct me if that is wrong, we're looking at all of these controllers right now. They're not supported yet because we've tried to do our first integration with the OpenDaylight controller, but there's more than just the ones that you mentioned, Thomas, that we're looking into currently, right?
Yes, that's correct.
Okay. And there's one additional question that just popped in. How is this type of flow related to the StableNet flow measurement package? That is actually a really good one. I'm not sure if I'm able to answer that. Did any of you guys understand that? Mark, Thomas?
So, as far as I understand this question, he's talking about the StableNet NetFlow module, if I'm right?
Probably, yes.
So, this type of flow is a completely other concept. So, these flows are at first simple entries in the SDN switch itself, but there is a same concept on monitoring or measuring these flows, of course, but in the end it's a complete other aspect of StableNet. It has no relation to the NetFlow or flow measurement package.
Okay, I'm just asking if that is answering the question. I need a little feedback here. Other than that, I think you guys did a wonderful job. All of the other questions we answered. Some of them, again, we answered directly through chat. And there is another hint about a use case that we might need to supply. But we're getting to that one directly. I think that would be a little bit too complicated in this session in here. So if you have any other questions, we will leave this session open for a couple of more minutes. So if you have any other questions, just feel free to type them in, even so we cannot answer them directly, but we will get to every single question via email or phone if supplied. So once again, thank you, Mark and Thomas, and thank everyone for joining our session today. I mentioned it earlier, actually a couple of times, so recording of this webinar will be available to you tomorrow. We'll send you a short email with the link. And if you have any other questions that you don't want to type in here, then please feel free to contact either Marc, Thomas, myself, or any other member of the sales staff with Infosim. Well, thanks again for joining us today, and enjoy the rest of your day. Goodbye.
Thanks, everybody. Goodbye.
Goodbye.